Hey everyone, welcome back, and today let's solve Leetcode problem 2425 titled Bitwise XOR of all pairings. So we're given two zero-indexed arrays, nums1 and nums2, consisting of non-negative integers each. There exists another array, nums3, which contains the bitwise XOR of all pairings of integers between nums1 and nums2, which really just means every single integer in nums1 is paired with every single integer in nums2 exactly once. So we have all unique pairs, which we can obviously get with nested loops if we really need to, right? And of course, we're not actually given this nums3 array as an input. We're basically given that we're existing another array nums3, which has the properties of containing the bitwise XOR of all the pairs of integers between our two input arrays, nums1 and nums2. We need to simply return the bitwise XOR of all the integers in nums3. Right, which again is basically that separate array that we know exists, which has the bitwise XOR of all the unique pairs of the numbers in nums1 and nums2, which are actually our input arrays. So let's go ahead and look at our example here. In this case, we have nums1 to basically be 2, 1, and 3, and nums2 to be a length 4, 10, 2, 5, and 0. In this case, our output is 13 because one possible way that we can actually kind of form or get a nums3 array with a property would be 8, 0, 7, 2, 11, 3, 4, 1, 9, 1, 6, 3, right? And the bitwise XOR of all of these numbers would be 13, and so that's why we return 13. And the reason why this array works is it is indeed containing every single possible bitwise XOR operation done on all the unique pairs of numbers between these two input arrays, 2, 1, 3 and 10, 2, 5, 0, right? In example 2, we have our input array nums1 and input array nums2 to be 1, 2, and 3, 4 respectively, and in this case our output is actually 0, right? And for the explanation here, a little bit shorter, it says all the possible pairs of bitwise XORs would be nums1 at 0, XORed by nums2 at 0, or nums1 at 0 XORed by nums2 at 1, or nums1 at 1 XORed by nums2 at 0, and finally nums1 at 1 XORed by nums2 at 1. We have 4 different elements, 2 in each, and we have 4 different possible unique pairs of elements to choose from. And in this case, one possible array, after taking the result of all of these XOR operations between all the different possible pairings, would be the result of 2, 5, 1, 6. And if you take the bitwise XOR of all of these elements in our possible input array nums3, we see that would be 2 XORed by 5, XORed by 1, XORed by 6, which would give us a return value of 0, and so we'd return 0 in this case. So for the constraints here, we see that the length of our input array nums1 and nums2 are not going to exceed either of them 10 to the power of 5, and they're going to be at least 1. And we see any value as such at any index I in both of these input arrays are not going to exceed 10 to the 9th power and are going to be non-negative, right? As the problem states as well, right? So with the problem statement examples and constraints out of the way, I will give you guys a few seconds. I'm going to just go over this problem in your head and think of a valid solution. And then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so what is one kind of very important observation that we can really make to help us lead to our solution? Well, that really is that the XOR, again, if you remember, is basically a bitwise operation where if you XOR two identical bits, the result would be 0. But if they're different, like 1 and 0, and not 1 and 1 or 0, 0, the result is 1. That's kind of a high-level rundown of how the bitwise XOR operation really works. So if you're XORing, like, per se, a bit 1 and 1, if we XOR these two bits, we get a result of 0. The reason why is because they're both identical bits. But if we XOR the bit 1 by 0, we'd get a result of 1, right? Because 1 and 0 are different bits. Okay, that's kind of a high-level rundown of how bitwise OR really works, all right? And that's very important to actually solve this problem. The reason why is because kind of a high-level rundown of our solution, how we're going to actually solve this problem. Basically, we're going to use two variables XOR1 and XOR2 to store the cumulative XOR of all the elements from nums1 and nums2, respectively, right? And once we actually get that, we'll actually iterate over both the arrays to actually calculate those cumulative XOR values and build up our XOR1 and XOR2 values. And based on whether the length of nums1 and nums2 is odd, or if it's even, will actually help determine our final result. More on that once we actually get to the code. But again, to reiterate, on a very high level rundown, basically we're first going to compute the cumulative XOR of both nums1 and nums2, and based on the length, whether it's even or odd, of each list, we'll modify that result accordingly, right? So now with that high level rundown out of the way, let's go ahead and get straight into the code here. So first of all, like we just talked about, let's actually initialize our XOR next to cumulative values, or integers as such. So XOR1 and XOR2, and they're going to be initialized to 0 each. So in this case, 0 and 0 respectively. And to reiterate what these two things really do, these integers simply store the cumulative XOR of all of the elements in nums1 and nums2 respectively for XOR1 and XOR2. And that XOR operation is going to always start with 0 because, of course, XORing anything with 0 would just leave that result number unchanged, right? It would keep it exactly the same. So now let's actually initialize the first pass for nums1 to build up this XOR1 cumulative value. So for every single number in nums1, our original input array, or our first input array, we're going to XOR 1 and XOR that value by the current number, that cumulative XOR, right? And we're going to XOR this XOR1 value for every single value accumulatively, or num, in this input array at every single iteration. Right, we're applying as such for every single number, or for each num, the XOR operator to XOR 1, right? And to kind of reiterate and kind of explain what this guy does, this is actually the XOR operator, right? And the way this works is basically it updates the value of XOR 1 by XORing it with the current element in nums1, which would be this num iterator right here. And as we actually do that, that way we'd actually accumulate the XOR for all of the elements in nums1. And of course, once this for loop is actually done executed, once it actually terminates, XOR1 would actually have the cumulative XOR for all the elements in nums1. Right, so very similar approach for the second input array. So for every single num, I'll just say in nums2, our second input array, we're going to do the same exact thing, but instead with XOR 2, because that's responsible for the cumulative XOR for all of the elements in the second array, right? So we're going to XOR it by num. Very similar logic here. Again, we're simply iterating through every single element in nums2, and for every single element, or num, or number as such, we're going to update or kind of increment that XOR 2 by XORing it with num. Right, that makes sure that XOR 2 would then store the cumulative XOR of all the elements in nums2, right? Very straightforward approach, very, very concise approach. Now to actually help determine the final result, and of course to first do that, we have to actually initialize it. So I'm going to initialize it to be 0, because of course we haven't actually done anything yet, but this is eventually going to store the final result of that operation based on the length of nums1 and nums2. Okay. So what exactly is that condition based on the length of the nums1 and nums2 input arrays? Basically, if the length of nums2, if we actually mod that integer value, or that length, by 2, if it's not divisible by 2, meaning if it's not actually equal to 0, then we know we have to get the result and XOR it by XOR 1. Right? Really, this is the main observation that we should really make here. Right? That is, whether the length of the array is odd or even, that's always going to affect that final result, right? Basically, if the length of nums2 is odd, meaning the length of our nums2 input array modded by 2 is not equal to 0, if that's the case, well then we have to XOR the result with XOR 1. And that really means that the cumulative XOR of nums1 would actually contribute to the final result if nums2 actually has an odd number of elements. Right, and very similar approach with the initial array now. If the length of, in this case, nums1, our initial input here, modded by 2, if that's not equal to 0, meaning if we do actually have a remainder, if it isn't actually divisible by 2, we know it has an odd length, and so if this also has an odd length, we'll OR the element, or bitwise OR the element, with XOR 2 as well. Alright, so very similar logic as you can see in this solution here. Basically what we're really doing here on line 11 and 12 for this conditional, if the length of nums1 is odd, very similarly, then we had to XOR the result with XOR 2. And that's going to make sure that the cumulative XOR of nums2 is also going to contribute to the final result if nums1 has an odd length, or an odd number of elements. And finally, once we're done with both of those conditionals and operations, once the for loop's actually done execute, we simply have to return our result. Whatever that stores, that's basically going to now hold the XOR of the appropriate cumulative XORs from both of the arrays based on the lengths of nums1 and nums2, right? So as you can see, if I were to submit this, this would actually work, and this would be a valid solution. And as you can see, this is really just about as efficient as you can really get it to be. So to kind of reiterate how this code actually works as a whole on a high level breakdown here, basically, we're going to compute the cumulative XOR of both of the arrays in the XOR1 and XOR2 integers, and then we're actually going to check the length of both of the arrays, right? And if the length of either array is odd, as we see in the conditionals from line 9 till 13 here, if either of the lengths of either array is odd, well then we'd have to XOR the result with the cumulative XOR of that array. And the key there in actually doing that operation is that this result is actually built step by step. And based on the lengths of the array, we have to actually decide which XOR value to actually include or exclude based on the length of our two input arrays. Again, because we have to actually bitwise OR all of the pairings of the integers between those two input arrays, nums1 and nums2, right? So for the time complexity here, this is actually going to be a big O of n plus m solution, right? N and m are going to be the lengths of nums1 and nums2 respectively. Why is that? Well, because we literally have two different for loops here, two different passes, and each of them iterate over one of the arrays. This guy is a big O of n operation for the original input, and this guy is a big O of m operation for the other input. So this is going to be a big O of n plus m operation. We have two different passes for both of the two different input arrays, looping through every single element in both of the arrays exactly once. And for the memory or space complexity, believe it or not, this is actually going to be a constant time space complexity of big O of 1. That's really because we're only using a few extra integers variables here like XOR1 and XOR2, and the result, they're all integers though. We're using a constant amount of extra space, and we don't actually use any auxiliary memory or any extra data structures, and so we're not actually depending on the size of the input arrays for our space or memory usage. And so for that reason, the memory complexity is going to be a constant time big O of 1 solution. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.